All right, I'm going to go over the fraction of a fraction method for multiplying. So fraction of a fraction is really reading this fraction, this multiplication problem, 3/5 times 2/7 as 3/5 of 2/7. So interpreting multiplication as of isn't that strange when we're thinking about fractions. So in order to show this, I'm going to start by showing 2/7. So here's my whole. This rectangle is my whole. And I'm going to try and divide it into 7ths. Okay, that's not too bad. Oops. And as always, when we're doing sketches, we're going to assume that these are all equal because we know when we're doing fractions, we need to have equal parts. So here's my 1, 2, 3, 4, 5, 6, 7 pieces. I want 2 of them. So I'm going to shade in 2 of those 7 pieces. 1, 2. So here's my 2/7. Okay. Now, I want 3/5 of that 2/7. So I'm going to take that shaded area, and that's basically I'm going to think of as almost for a minute my new whole. I'm going to take that 2/7. I'm going to split it up into fifths so that I can show 3/5. So let's see if I can split this into fifths. 1, 2, 3, 4. So 1, 2, 3, 4, 5. Okay, so I've split that into fifths. Let's see, is that kind of hard to see? Maybe I'll go back over that in black. So 1, 2, 3. So 1, 2, 3, 4, 5 equal pieces. Now, because I want 3/5, I'm going to shade in 3 of those. So 1, 2, 3. So I've shown 3/5 of 2/7. Now to get my final answer, I'm going to relate that back to my original whole. That is my original rectangle. Now notice that when I split my 7ths into fifths, I could continue that for the rest of this shape. Okay, when I do that, I've split my whole into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35 equal pieces. So I now have 35 equal pieces. My whole is split into 35 equal pieces. Of those equal pieces, I'm going to look at which one of them are double shaded or which one of them represent the 3/5 of the 2/7. So that's this piece, 1, 2, 3, 4, 5, 6. So 6 out of those 35 make up the 35 of 2/7. So my final answer is 6/35. Notice that's the same thing you get if you use the standard algorithm for fraction multiplication, which is to say we multiply across the top, multiply our numerators, and multiply our denominators. Okay, let's do one more example of fraction of a fraction method. And let's pick something this time where one of our numbers, one of our fractions, is improper, meaning it represents something bigger than 1. So let's do, I don't know, how about 3/4 times, how about 7/3? Okay, so 3/4 times 7/3, or we can think of this as 3/4 of 7/3. So I'm going to start off by drawing my 7/3. Now let's think about what 7/3 really means. It means I have 7 equal pieces. Each piece is worth 3. Sorry, it's not worth 3, it's worth 1/3. Sorry. So here's one whole. If I split that into thirds, if I split that into thirds, there's 1, 2, 3 thirds. So now I'm at 3/3, but I need to get to 7/3. So I gotta draw another hole. split that into thirds. So 1, 2, 3, 4, 5, 6. So now I'm at 6 thirds. I need another hole. All right. So it takes me 1, 2, 3 holes, but now I've shown 1, 2, 3, 4, 5, 6, 7 thirds. Notice that this also shows me that 7 thirds is the same thing as 1, 2, and a third. Neither here nor there for this problem. All right. So now I want to show 3/4 of that 7 thirds. Okay. So I'm going to take my blue colored in part, which shows the 7 thirds, and I'm going to split it into fourths. All right, so now I've got 1/4, 2/4, 3/4, 4/4, and I'm going to color in 3 of those fourths because I want 3/4. So 1/4, 2/4, 3/4. Okay, so now my answer is going to be the double shaded stuff. But I need to kind of think about, okay, what is that all together? Well, remember that one of these is my hole. So one of these is my hole. My hole has been split into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So each of those little squares, those little rectangles, is representing a 12th. Of those 12ths, how many of them are double colored, or how many of them are representing my 3/4 of 7 thirds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Phew. So this picture shows that 3/4 times 7 thirds equals 21/12. If we were to do our standard algorithm, 3 times 7 over 4 times 3 is certainly 21/12. Now one thing to notice is this does not necessarily give us our answer here in lowest terms or simplified terms, but that's okay because in the beginning when we're trying to teach students to multiply fractions, we're worried more about the conceptual understanding and saying, do you understand what this means? Can we model this? Can we get an understanding of where we're going with this? Simplification, we can work on that separate, and eventually the two will come together very nicely. So that's the fraction of a fraction method for multiplying fractions.